The question is, who's involved in this race to perfect quantum computers? And the answer is everyone. Well, the arrival of quantum computers could be even more historic than that. We're now at the initial stages of the next revolution.
Michio Kaku never disapproved of the infinite potential of artificial intelligence. It's the era where AI might just be the solution to the unknown, the big mystery of other intelligences out in space beside humanity. For almost half a century, both Voyagers 1 and 2 have been up there. No one knows what might have bumped into it, or who might have attempted controlling it. Are the data sent to Earth just normal signals from the spacecraft, or some geeky guests are behind it? Using the Voyagers to talk back? A curious possibility. Back in 1977, when NASA launched Voyager 1 and Voyager 2,
it actually happened last year, but NASA only confirmed the data on Thursday.
No one knew just how far they would go, or how long they'd last. These two robotic emissaries were sent to explore the outer planets, but NASA had a much bigger vision. Send them beyond our solar system into deep space, where, just maybe, someone else might find them. And just in case that happened, the Voyagers were equipped with a golden record, a gold-plated, phonograph-style disc containing greetings in multiple languages, music from around the world, sounds of nature, and images showing life on Earth. It was humanity's way of saying, "Hello, we're here." That idea alone is pretty bold. We basically threw a message in a bottle into the cosmic ocean. But what if that message has been found? What if someone out there, an intelligent extraterrestrial civilization, intercepted Voyager, examined it, and decided to reply? Let's unpack that for a second. If an alien species were advanced enough to detect and retrieve Voyager, they'd likely have the technological capability to understand our signals, or at least know they are signals. The Golden Record includes instructions on how to play it, along with diagrams and mathematical patterns designed to be universally recognizable. If they cracked that code, they'd get a small but fascinating glimpse of Earth and its people. And if they were curious, they might want to answer in kind. Now, this is where things get especially interesting. One fun and speculative idea is, what if those extraterrestrials didn't just send their own signal into space, hoping we'd pick it up? They actually used our Voyager to communicate back. Maybe they modified its hardware, redirected its signal, or added data packets in a way that we'd recognize once it returned to Earth. Imagine NASA getting a data transmission from Voyager 1 that suddenly contains unknown code, or a pattern that defies any known human language or engineering. It would be historic. Of course, we have to be realistic. The chances of that happening are incredibly slim. For starters, the Voyagers are very old, almost 50 years in space. Their systems are outdated, their power sources, radioisotope thermoelectric generators, are running low, and they can only send tiny bits of data back to Earth. Also, the data they do send is constantly monitored and analyzed by NASA's Deep Space Network, a global system of massive antennas. So far, nothing out of the ordinary has come through. No alien code, no weird anomalies we couldn't eventually explain as technical hiccups or aging hardware. That said, the idea still captures our imagination, and for good reason. Voyager represents one of the purest forms of hope and curiosity in human history. We launched the spacecraft not just to study planets, but to reach out into the unknown. We assumed the odds of contact were low, maybe even near zero, but we did it anyway, because even the tiniest chance of discovering we're not alone is worth the effort. Are aliens using the Voyagers to talk back? Probably not, but could they? That's a harder question to dismiss completely. If we're willing to entertain the idea that intelligent life exists elsewhere in the universe, and many scientists do, then it's not unreasonable to think such a civilization might notice one of our space probes. Maybe they'd be intrigued. Maybe they'd reply using whatever method they thought we could understand. If not, perhaps AI can detect it. The limits of AI. Kaku views today's AI as a sophisticated tool rather than a sentient entity. He likens it to a glorified tape recorder, emphasizing that current AI systems process and generate content based on existing data without true understanding or consciousness. From recommending movies to diagnosing diseases, AI is everywhere and getting smarter by the day. But here's a more cosmic question. Could AI help us detect if something unique, something we didn't expect, maybe even something non-human, was sending data from or through the Voyager spacecraft? It's not as far-fetched as it sounds. The Voyager probes are still out there, floating at the edge of our solar system and beyond, sending back little streams of data. These transmissions are incredibly faint, but they still contain valuable information about cosmic rays, magnetic fields, and other phenomena in deep space. NASA's Deep Space Network catches these signals and processes them using powerful systems, many of which already use automated data analysis and AI-like algorithms to sift through the noise. After all, it's not easy decoding something that has traveled billions of miles across space. Here's where it gets interesting. AI is really good at spotting patterns, especially ones that humans might miss. Imagine if, buried within Voyager's usual data stream, there was something just a little off. Maybe a subtle change in rhythm, or a sequence that doesn't match any known command, protocol, or cosmic event. A human analyst might not think much of it. It could easily be chalked up to interference or a glitch in the old spacecraft. But an AI trained to detect anomalies could flag it, saying, "Hey, this doesn't match the usual Voyager behavior. You might want to take a second look." That second look could be the beginning of something huge. Let's be clear though. AI can't tell us if the anomaly is alien or even intelligent. It just knows what should be there, and it's great at identifying what doesn't belong. It's kind of like a smoke detector. It won't tell you what's on fire, but it'll let you know something's burning. That's where human researchers still come in. AI can filter through mountains of space data at lightning speed, highlighting the weird stuff for us to investigate. And with so much data coming from all directions, Voyager included, having a digital assistant with that level of attention is a game changer. Now imagine AI systems hooked directly into the raw data streams from Voyager, running 24/7, comparing every byte to decades of historical telemetry. With machine learning models trained on all the normal behavior of the spacecraft, it could notice even the smallest oddity. A repeating pattern where there shouldn't be one, a slight modulation in frequency, a piece of data that seems too structured to be random static. Could it be aliens hacking our space probe? Probably not. Could it be something new? Maybe a natural phenomenon we've never recorded before, or even a technical hiccup we don't yet understand. That's entirely possible, and AI could be the first to notice. Of course, there's also the risk of false alarms. AI is powerful, but it's not perfect. It might flag a cosmic ray as a signal, or mistake old, corrupted data for a new pattern. That's why AI is best used as a tool, not the final judge. It raises the red flag, and we investigate. It doesn't jump to conclusions about extraterrestrials. That part's still up to us, and our imaginations. In the end, using AI to monitor spacecraft like Voyager,
The Voyager 2 spacecraft has crossed the boundary that marks the start of interstellar space.
is less about expecting alien contact, and more about not missing anything important. It's like putting a hyper-vigilant listener on the line, one who never sleeps, never gets bored, and never overlooks the tiniest whisper from the stars. Whether it's a bizarre glitch, an unexplained energy burst, or something truly unprecedented, AI ensures we don't miss the moment when the universe might be trying to tell us something. With the right tools, the right data, and a little cosmic curiosity, we're better equipped than ever to find out. After all, we built the Voyagers to explore the unknown, the possibility of other intelligence in the universe. It's one of the oldest and most profound questions we've ever asked ourselves. Are we alone in the universe? From ancient civilizations who looked to the skies and imagined gods, To modern scientists scanning the heavens with powerful telescopes and radio receivers, the possibility of other intelligent life has fascinated us for millennia. As our understanding of space grows, so does our curiosity, and perhaps even our confidence, that intelligent life may exist somewhere out there in the vast cosmic ocean. Let's consider just how big the universe is. Our home galaxy, the Milky Way, has somewhere between 100 to 400 billion stars. Many of those stars have planets orbiting them, so-called exoplanets. In fact, thanks to missions like Kepler and TESS, we now know that planets are incredibly common. Statistically, there could be billions of Earth-like planets just in our galaxy alone. Now, zoom out. The Milky Way is just one of an estimated 2 trillion galaxies in the observable universe. The sheer numbers almost seem to demand that intelligent life exists elsewhere. It feels arrogant to think that out of countless stars and planets, only one world, ours, has developed minds capable of asking these questions. But numbers alone don't give us proof. We have to think about what intelligence means. If we're talking about bacteria or simple life forms, the odds seem pretty high that life has arisen elsewhere. But intelligence, like human-level consciousness, language, tools, civilizations, that's a much higher bar. It's possible that intelligent life is incredibly rare. Maybe the conditions have to be just right, not only the right kind of planet and atmosphere, but also a long period of planetary stability, a big moon to regulate tides, a magnetic field to block radiation, and perhaps even a few cosmic near misses to shake things up evolutionarily without completely wiping everything out. Earth might be lucky in a way that's statistically improbable. Still, the idea that intelligent life might have developed somewhere else isn't purely science fiction. The famous Drake equation, developed by astronomer Frank Drake in the 60s, attempts to estimate how many technologically advanced civilizations might exist in our galaxy. While many of the variables in the equation are still unknown or speculative, even conservative guesses often suggest that there could be multiple civilizations out there, though maybe separated by vast distances in space and time. Even if intelligent life exists, why haven't we heard from anyone? Do you have a theory about this? The comments section is open. Let's continue. This is the core of the Fermi paradox, named after physicist Enrico Fermi, who once asked, "Where is everybody?" Given the age of the universe and the potential for advanced civilizations to travel or communicate across the stars, it seems like we should have encountered signs of alien intelligence by now. But so far, radio silence. No definitive signals, no ships in the sky, no interstellar messages. There are dozens of theories to explain this paradox. Maybe civilizations tend to self-destruct before reaching the capability to explore space. Maybe they're deliberately hiding. Maybe they're just too far away or using forms of communication we don't understand. Or maybe, just maybe, we really are alone. Then again, we might simply be too early. Humanity has only had the ability to send and detect radio signals for just over a century. That's barely a blink in cosmic time. Imagine if an alien civilization existed 1,000,000 years ago, but died out long before we even invented agriculture. Or imagine a species that won't evolve for another 1,000,000,000 years on some distant planet we can't yet detect. In the timeline of the universe, intelligent civilizations might be like brief sparks, rarely overlapping. Our failure to find them so far might not mean they don't exist. It might just mean the timing hasn't lined up. Another thing to consider is how alien intelligence might be. Well, alien. We tend to imagine extraterrestrial life as kind of like us, carbon-based, biological, maybe humanoid, but it could be something wildly different, perhaps based on silicon instead of carbon, or even some form of digital or post-biological intelligence. We might not even recognize it as life if we saw it. And if it's that different, communication could be next to impossible. Think about trying to talk to an octopus or a dolphin, and multiply that challenge across the galaxy. Despite all these uncertainties, many scientists remain optimistic. Projects like SETI, Search for Extraterrestrial Intelligence, continue scanning the skies for signals. Others suggest looking for techno-signatures, signs of advanced technology like artificial light, satellite swarms, or large-scale energy use. Meanwhile, astrobiologists are exploring the potential for life on nearby moons like Europa or Enceladus, and even on Mars. While these places may not harbor intelligent life, finding any life beyond Earth would change everything. It would prove that we're not the only game in town, and raise the likelihood that intelligent life might also be out there, somewhere. Mysterious and unsolved signals and objects from outer space. The universe is a noisy place, not noisy in the way a crowded street or a busy cafe might be, but full of signals, pulses, strange objects, and events that defy explanation. Some of these phenomena are cosmic in origin and perfectly natural, but others, well, they leave scientists scratching their heads. From eerie radio bursts to bizarre interstellar visitors, space has sent us its fair share of mysteries. And while science has solved many puzzles over the years, some signals and objects remain unsolved, lingering on the edge of science fiction and science fact. Let's start with the classic, the WOW signal. On August 15, 1977, astronomer Jerry Amon was working with the Big Ear radio telescope at Ohio State University when he noticed a bizarre radio signal. It was unusually strong and lasted for 72 seconds, coming from the direction of the Sagittarius constellation. Amon was so impressed, he wrote "Wow" in red ink next to the signal printout, hence the name. The signal fit what scientists thought an extraterrestrial transmission might look like. But here's the strange part, it was never detected again. Despite multiple follow-up attempts, the WOW signal remains a one-time event. Was it aliens? A distant star flaring up? A secret satellite? Nobody knows. To this day, it's one of the most tantalizing space mysteries ever recorded. Then there are the fast radio bursts. Short, powerful bursts of radio waves from deep space that last only milliseconds but can release as much energy as the sun does in a day. The first FRB was discovered in 2007, and since then, dozens have been recorded. Most come from billions of light years away, and scientists still aren't sure what causes them. Some theories suggest exotic neutron stars or black holes. Others have flirted with more far-out ideas, like advanced alien technology, perhaps huge planetary energy beams. Making things weirder, a few FRBs have been found to repeat, but not on a regular schedule. One repeating FRB even had a pattern, 16.35 days of silence, then a few days of bursts, then silence again. It almost feels like a cosmic heartbeat, or a signal we just don't yet know how to understand. And what about physical objects? In 2017, astronomers spotted something truly weird entering our solar system, named Oumuamua, which means scout or messenger in Hawaiian. It was the first known interstellar object to visit us from outside the solar system. It didn't behave like anything scientists had seen before. Its shape was unusually long and thin, like a cigar or a pancake, depending on the model, and it was tumbling oddly through space. It also sped up as it moved away from the sun, which made no sense if it was just a rock. Comets do that when they release gas, but Oumuamua didn't show any visible signs of outgassing. Harvard astronomer Avi Loeb even proposed that it might be alien technology, perhaps a defunct solar sail. Most scientists lean toward natural explanations, but the truth is, we just don't have enough data to be sure. Whatever Oumuamua was, it came and went quickly, leaving more questions than answers. Not long after, in 2019, another interstellar object showed up, 2I Borisov, a comet this time, and much more like what we expected from interstellar visitors. Unlike Oumuamua, Borisov behaved like a normal comet, with a tail and gas emissions. But its arrival confirmed something big. Objects from other star systems do pass through ours, and maybe more often than we realized. If two showed up within a few years of each other, could that mean there are more out there? Maybe some we've missed. Let's not forget the Black Knight satellite, a favorite among conspiracy theorists. Supposedly, this mysterious object has been orbiting Earth for thousands of years, possibly of alien origin. It gained attention after NASA released photos of what looked like a dark, oddly shaped object in orbit during a shuttle mission. Most scientists dismiss it as space debris, probably a piece of thermal blanket that came loose. But to this day, the Black Knight legend persists in online forums, documentaries, and curious minds who want to believe that someone, or something, is watching. Another mystery that stirred attention was the Tabby's star, also known as KIC 8462852. This star would occasionally dim in irregular and dramatic ways, with up to 22% of its light disappearing for days or even weeks. That's far too much to be explained by a planet passing in front of it. Some scientists speculated it could be a huge cloud of dust or comet fragments. Others proposed the wild idea of a Dyson sphere, a massive alien structure built to capture a star's energy. Though follow-up observations suggest natural causes, the initial mystery got people dreaming again about the possibility of advanced alien engineering. All these examples point to a broader truth. Space is full of strange, unexplained phenomena, and our understanding of the cosmos is still in its early chapters. We're like toddlers wandering into a library full of ancient books, picking up pages, trying to decode what it all means. Most of what we find probably has a perfectly natural explanation we just don't understand yet. But every now and then, a signal, object, or flash of light makes us wonder if we're seeing something more. Thanks to the Voyagers, we've come to know certain and absolute information beyond our home planet. Let's look back at their revolutionary contributions and discoveries of NASA's V1 and V2. Voyagers since the years. Originally designed for a 5-year mission to study Jupiter and Saturn, these two spacecraft have far outlived their expected lifespans, becoming the longest operating space missions in history. What started as a relatively short tour of the outer planets has turned into a mind-blowing interstellar journey, with both Voyagers now cruising through the outer reaches of our solar system and beyond. The story begins with an ambitious plan known as the Grand Tour. Thanks to a rare planetary alignment, NASA scientists realized they could send a spacecraft on a gravity-assisted slingshot path to visit multiple gas giants in a single trip. This alignment only happens about once every 176 years, so they had one shot at it. Voyager 2 launched first in August 1977, followed by Voyager 1 in September. Despite the numbering, Voyager 1 was on a faster trajectory and reached Jupiter and Saturn before its sibling. The encounters with the giant planets were nothing short of historic. Both Voyagers sent back jaw-dropping images of Jupiter's Great Red Spot and Saturn's icy rings, revolutionizing our understanding of the solar system. Voyager 2 went on to visit Uranus and Neptune, making it the only spacecraft ever to do so. Along the way, they discovered dozens of new moons, active volcanoes on Io, bizarre magnetic fields, and rings we didn't even know existed. The data was rich, and it changed science textbooks forever. What makes the Voyagers especially impressive isn't just the science. They're a testament to human engineering. These spacecraft were built in the 70s, using technology that today would seem ancient. They store data on tape recorders and communicate using a 20-watt transmitter. That's weaker than the average light bulb, yet they're still able to send signals back to Earth, even from billions of miles away. NASA's Deep Space Network has to use dishes the size of buildings to pick up the whisper-like signals they send. It's like trying to hear a watch ticking from across the country. Both Voyagers are powered by radioisotope thermoelectric generators, RTGs, which convert heat from decaying plutonium into electricity. These power supplies degrade over time, which means mission engineers have had to get creative, turning off non-essential instruments and heaters to keep the key systems running. It's like keeping an old car running long past its expiration date, except that car is 15 billion miles away, and you can't exactly pop the hood. Even more amazing is the fact that Voyager 1 became the first human-made object to enter interstellar space in 2012, with Voyager 2 following in 2018. They are now in regions where the solar wind is no longer dominant and are feeling the effects of particles and magnetic fields from the galaxy itself. We've never been there before, and yet these little spacecraft, which started their lives snapping family portraits of planets, are now pioneers in the great cosmic unknown. Of course, their time is running out. By around 2025, they'll run out of power entirely and fall silent. No more data, no more updates, just silent travelers drifting through space. But even after they stop talking to us, they'll keep going. Each Voyager carries a golden record, an ambitious time capsule containing sounds and images from Earth, including greetings in dozens of languages and music from Bach to Chuck Berry. The idea is that if an intelligent alien civilization ever stumbles across them, they'll learn a bit about who we are. Discoveries. The Voyager missions, Voyager 1 and Voyager 2, are like the rock stars of space exploration. Launched by NASA way back in 1977, these twin spacecraft have achieved some of the most mind-blowing milestones in space history. Originally intended to last only a few years to explore the outer planets, they've ended up giving us decades of jaw-dropping discoveries. Even now, they're out there, drifting through interstellar space, still sending back data. It's kind of like your grandparent texting you from another galaxy. So let's talk about what makes them so iconic. Voyager 2 actually launched first on August the 20th, 1977, with Voyager 1 following shortly after on September the 5th, 1977. Even though Voyager 2 launched earlier, Voyager 1 took a faster route and overtook it, hence the numbers. The main goal was to take advantage of a rare planetary alignment that happens only once every 176 years, allowing a spacecraft to slingshot from one planet to the next using gravity assists. This maneuver saved a ton of fuel and cut travel time dramatically. Using this trick, the Voyagers were set to visit Jupiter and Saturn, and possibly more. What followed was beyond what anyone expected. Voyager 1's flyby of Jupiter in 1979 was a game-changer. It sent back stunning images of the planet's swirling storms and, more importantly, revealed that Jupiter's moon Io was volcanically active, something no one had seen before. This was the first time active volcanoes were observed beyond Earth. That alone would have been worth the mission, but then it also captured the complex structure of Jupiter's rings and gave us clearer images of moons like Europa, which now we know might have a subsurface ocean. Meanwhile, Voyager 2 did its own Jupiter flyby, giving us more detailed images and even better close-ups of Jupiter's great red spot and its moons. Then came Saturn, and again, both spacecraft delivered in a big way. Voyager 1 got a close look at Saturn's rings and its largest moon, Titan. Titan turned out to be really interesting. It has a thick atmosphere, unlike any other moon. Scientists were so intrigued by Titan that they actually changed Voyager 1's course to get a better look, which meant it couldn't go on to Uranus and Neptune. But that was okay, because Voyager 2 picked up the baton. Voyager 2 is actually the only spacecraft ever to visit Uranus and Neptune. When it flew by Uranus in 1986, it discovered 10 new moons, 2 new rings, and got the first good look at its oddly tilted magnetic field. The planet itself turned out to be a lot less flashy than Jupiter or Saturn, but its weird sideways rotation and icy moons, especially Miranda with its bizarre patchwork-like surface, made it a highlight. Then, in 1989, Voyager 2 reached Neptune. That flyby revealed a stunning blue planet with supersonic winds and a dark storm known as the Great Dark Spot. It also discovered 6 new moons and more rings. Triton, Neptune's largest moon, turned out to be geologically active too, with geysers spewing nitrogen gas. These discoveries were just wild. No one expected these distant worlds to be so dynamic. After they wrapped up their planetary tours, the Voyagers kept going. NASA realized they were still healthy, so they transitioned to the Voyager interstellar mission. That's when things got even more philosophical. In 1990, Voyager 1 took the famous pale blue dot photo, an image of Earth from about 3.7 billion miles away. In the photo, Earth is just a tiny speck suspended in a sunbeam. That image inspired Carl Sagan's poetic reflection on our place in the universe and is now one of the most iconic space photographs ever taken. Eventually, both spacecraft crossed into interstellar space, Voyager 1 in 2012 and Voyager 2 in 2018. This means they passed the heliopause, the boundary where the sun's solar wind is no longer dominant. It's like crossing over from the bubble of our solar system into the rest of the galaxy. Out there, they've been measuring cosmic rays, magnetic fields, and particles in the interstellar medium. It's a treasure trove of data that we've never had access to before. Oh, and let's not forget the Voyager Golden Records. Both spacecraft carry a gold-plated audio-visual disc that contains sounds and images representing the diversity of life and culture on Earth. Greetings in 55 languages, music from around the world, and even sounds like thunder and a baby crying. It's like a message in a cosmic bottle, just in case some alien civilization ever finds them. The idea was wild and hopeful and very human, and it's one of the reasons people still feel emotionally connected to these spacecraft today. So here we are, nearly 50 years after launch, and the Voyagers are still talking to us. Whether it's volcanoes on Io, new moons around Uranus, or the winds of interstellar space, the Voyagers have given us more than just science. They've given us perspective. Not bad for a pair of 70s robots running on less computing power than a modern calculator. Thanks for watching the video. Continue to support us by subscribing to the channel.